All right, so let me bring up this program. It's right here, and then we're on chapter 1, and we are on 1.7. So let's see what they have for us. All right, you still might want to jot some of these things down. Yes. All right, so here we are, section 1.7. Three-dimensional figures this time. It's not two-dimensional. They're not flat. Okay, they actually have some depth to them, and you'll see what we're talking about here in a second. This starts us off. Let's do this. The different types of solids. So these things are solids. So this is what I want to get to. All right, so let's take a look at this. You'll probably see a picture like this in the book. Let me flip through right here. You'll probably see something almost identical to this, if not exactly like this. Let's see, 1.7, and sure enough. Now, they're not giving you the formulas just yet. They will. Yeah, on page 67, if you look at page 67 in the book, this exact thing is in the book. But I just used this program today just because it looks a lot neater than me trying to draw these things or grabbing them off the internet or something, right? Let's take a look at this first word right here as a polyhedron. Okay, a polyhedron, they have a definition in the book on page 67. It's a flat surface. It's a solid with all flat surfaces that enclose a single region of space. So you have all flat surfaces. A polyhedron is not curved. So do you have all flat surfaces right here? Yeah. Yes, you do. It's a solid as well, right? It's all enclosed, right? And there's no gaps in it, so that's a polyhedron. Kind of like a polygon, except it's like a three-dimensional polygon, right? It's got some height to it, right? It's not just one flat surface right here. It's got some height, and it's got stuff inside there, and it's all closed up, right? There's no open faces, there's no gaps or anything like that, all right? So let's talk about the first word. So these are all polyhedrons except the ones with curves. Look at these. See, that has a curve? It's a circle. This is curved, right? It's got a circle. This is curved. It's got a circle. These are not polyhedrons. Polyhedrons are only flat surfaces, okay? They're flat. They're not curved. Does that make sense? All right. So that's what a polyhedron is. Let's take a look at this specific type of polyhedron. It's a prism, right? So a prism, it's a polyhedron with two parallel congruent faces. Now, when we say faces, they call them bases, all right? So look, the top and the bottom, that's what I call it. See the very top? See the bottom? We call that a base. Now, what's true about those two bases? Does one slant this way and one slant like this way, and they come to a point? No. What is it? They're both parallel to each other, all right? So this base and this base are parallel to each other. So a prism, the top and the bottom are going to be exactly the same. So the base, it's got two bases, not just one. It's got one on the bottom and one on the top, and they're exactly the same, all right? And it says it's connected by parallelogram faces. Now, I find it odd that they would even use that word parallelogram because we haven't even discussed a parallelogram yet, all right? But that's, the faces are these things. Do you see this side right here where I'm pointing to? See that arrow? That's a face. This is a face. This is a face. Now back here, right? It's kind of see-through, right? See back here, this little rectangle? That's a face, and this is a face. Make sense? So we got bases and faces, all right? The bases are the top and the bottom. The faces are the sides, if you want to call it that. They're the sides. That's a prism. You could have all kinds of different shapes of a prism. This prism, what's the base? What kind of a shape is the base of this? How many sides does it have? 1, 2, 3, 4, 5. Right. So the base is a what kind of a figure? It's a pentagon. Right. So we call this, you might want to write this down, we call this a pentagonal, write it down. We call it a pentagonal prism, right? Because it's from a pentagon. Is anybody writing this down? I see 3 people writing. Okay, write it down. Daniel. All right, it's a pentagonal prism. But you could have a rectangular prism. You could have a triangular prism. What's the difference between a triangular prism and a pentagonal? Or, okay, yeah, it's the base. It's the number of sides that the base has. All right. So depending on how many sides the base has, we could name it a certain type of prism. But they all go straight up. They have a flat surface. They all go straight up. Notice, do you see this thing right here? It's perpendicular to the base, isn't it? See this up and down? Everybody watching up here? Got a lot of stuff going on. Let's everybody up here. Thank you. So look at this thing right here. this up and down right here is perpendicular to the base. Do you see it? It's not slanted, right? So that's a prism. A prism, the sides are not slanted. They go straight up and down. Perpendicular. See the face, right? That side is perpendicular to the base. So the sides are perpendicular to the base. Everybody got that? Did anybody write that down in their notes? That the sides are perpendicular to the base? Good. I see 2 people shaking their head. Everybody else should have written that down. I said it like 3 times. That the sides are perpendicular to the bases on a prism. Write that down. Look at this. Look at a pyramid. Look at the difference between a prism. They both start with P. Sometimes I even get them mixed up a little bit when I say them. I got to think about it. A prism, it's got 2 bases. It's got a top and a bottom, right? And all the sides go straight up and down. Look at a pyramid, though. It does have a base. See? It's sitting on that bottom right there. But what do? Do the sides go straight up and down, perpendicular? No, they slant up to a what? To a point, right? And that point, obviously, is called the vertex, all right? Still a polyhedron because all the sides are flat, right? There's no curved sides to this, all right? It's got a polygon base. This base just happens to be what kind of a base? Yeah, it's probably a rectangle. Could be a square, I guess, okay? We'll say it's a rectangle. It's a rectangular base, all right? So it's a rectangular, what? Pyramid. What if there were 5 sides on this base? Then it would be a what? A pentagonal, all right? Pentagonal pyramid. What if it was a hexagon, 6 sides? Then we'd call it a hexagonal, right? Because we put the AL on the end of it, okay? So we'll call it hexagonal pyramid. But they all do what? They all come to a point, and that point is called a vertex. Exactly right. All right, so look, it's got a polygonal, okay, or polygonal, however you want to say it, okay, base, which means it's a polygon, right, of what? 3 or more triangular faces. Look at the faces on this one. What shape are all the faces? They were all rectangles on a prism. What are all the faces on a pyramid, though? They're all triangles. And it doesn't matter if you have a triangular base, a quadrilateral base, a pentagonal base. It doesn't matter. All the sides, all the faces are going to be triangles. Okay? That's a pyramid. So we got to know what these things are first before we figure out equations to find, you know, area and all that other kind of stuff. So we got to know what these things are first. That's what we're doing. Okay? What about this one? This is called a cylinder. All right? You've seen cylinders before, right? Look at the base on the cylinder. What kind of a base is this cylinder? It's a circle. It's kind of like a prism, isn't it? Okay? It's kind of like a prism because it's got 2 bases. They're both exactly the same, aren't they? The bottom and the top. And the sides go straight up and down. It's perpendicular, right? So if I went from this point all the way down to here, that would be perpendicular to the base. But look at the sides, though. The sides aren't rectangles. They're not triangles. Look at this. It's a what? It's basically kind of circular, isn't it? All right? It's circular. It's rounded, all right? And there we go. We just say it's connected by a curved surface. All right. That's a cylinder. A cylinder is kind of close to a prism, right? Look at this. A cone is kind of close to a what that we talked about? Kind of close to a pyramid because it's got one base and it all goes up to one point. And that point is called the vertex. Everybody see that? So a cone is kind of like a pyramid except the base of it, the bottom of it, is a circle this time. You got it? And it comes up to a point. All right, look at this thing. A sphere. It's kind of fun to say, isn't it? So a sphere is what? It's basically like a circle, but it goes all the way around. So it's, look, if you start from here and you go any direction at all, you go up and down, you can go out like this, out like this. If it's the same distance around from that one point right there, we call that a sphere. It's like a ball, right? But look at it. It doesn't have any faces, doesn't have any edges, doesn't have a vertex. It does have a center, though. All right, that little dot right there we would call the center of that sphere. Did anybody write that down? It's okay. The center of a sphere. You wrote that yesterday? We didn't talk about a sphere yesterday. A sphere? We didn't mention a sphere once yesterday. Talk about the center, but not a sphere. Not a sphere, though. I'm saying. Write down this. The dot in the middle of a sphere is called the center. All right. All right. Everybody got that? All right. So there's your explanation of what these shapes are. Now I think we're going to talk about the formulas. Okay, here's a little example. This is nice. Let's look at it. It says determine whether it's a polyhedron. First of all, is that thing a polyhedron?
No.
Yeah, because what's a polyhedron? All what? All the surfaces are flat, right? So all the surfaces are flat. There's nothing rounded on this thing at all. And it's closed in, isn't it? It's all closed. It's not just one flat surface. It's a solid with all the faces, okay, flat. Okay, careful with careful with the cord. So it's gonna rip this thing off here. Here, lift up. No. Lift up your desk. No. The leg was pushing against it. Lift up your desk. Right there. See, now you don't have to worry about it. That's all I was trying to get you to do. Because this is attached, and I don't want it to fall down. Okay, so identify the solid. If it's a polyhedron, which it is, right? We determine it is. Name the bases. So what are the bases of this thing? It's like the top and bottom. But what kind of a shape are the bases? It's quadrilateral, right? So I have to have 4 points. I can't just say it's C. I can't just say it's G. What about the top? Name the top for me. It would be what? Let's start at E. E, G, H, F. Right, so that would be one base, wouldn't it? Name another base. The bottom of it. What would be the bottom? Okay, let's start here. Let's start at A. So A, C, D, B. Right? So that would be the 2 bases. Everybody see that? What about the faces or the sides of it? Let's talk about this front one looking at us right here. Yeah, it doesn't matter what order you go, does it? I could go GCDH or I could go GHDC. It doesn't make any difference. All right? And then what about this side one, this one on the right? What would I call that? HDBF, right? What about this back one? EFBA. Again, it doesn't matter what order you go in as long as you go around the horn like this. And what about this left one? G what? CAE. Are you seeing what we're looking at here? It's kind of three-dimensional. It would be very difficult for me to draw, so that's why I went to this little program right here, because they got them all drawn for me. Okay? All right. Oh, they're just giving the answers to this. Okay, here's my thing. There it is. Thing. I guess that's what they're doing. I don't know. Maybe I skipped something. I don't know. It says determine whether the solid is a polyhedron. Is that a polyhedron? Yeah, it is. It's all flat and all. It's a solid, and they're all, there's no gaps in it. It says if it's a polyhedron, name the bases. So I would say it's got 2 bases, right? No. I would say this. Now, it doesn't look like it's sitting on this, does it? All right. But these sides go straight out like this. So it's kind of sitting on its side, isn't it? So this right here would be the base. And same thing right here. It's got 2 bases. Because you only have 2 bases on a... it doesn't have to be sitting. It doesn't have to be. Listen to what I just said. I said this thing is kind of sitting on its side, right? Oh. Because it's only got 2 of them. These would be all the faces. See this top one, this one on the side, this one here, the one it's sitting on. If you stood it up, yeah, exactly. If I tilted this up and put it on the end like this, that would be the base. Now, how many sides does this thing have? It's got 6, doesn't it? So let's start at K. I'd call it what? KPONML. That's what I would call it. That's one base. What would this base over here be called? Let's start with E and go this way. The EF what? GHIJ. That would be the base. You get the idea? All right, I'm not going to go through all of these. Oh, what about edges? Did we talk about edges? Edges are the sides. Are these actually not just sides, but it's where those 2 planes come together. So KE would be an edge, right? LF would be an edge. KL would be an edge. You see that? Where they form all these little line segments, those would be called edges. What about LF? Yeah, LF would be an edge. What about LG? Would LG be an edge? No. All right, from LG, there's no connecting thing between L and G. Yeah, they got to be connected they got to be connected, all right? L and G are not connected, are they? So I wouldn't call that an edge. What about a vertex? Vertices, that's plural. It'd just be all the points, wouldn't it? K would be 1, L would be 1, M, N, O, P, and just list them all. All right? So let's see what else we got. It says the solid is formed by polyhedron, so it's called a polyhedron. The base is a hexagon. The solid is a hexagonal prism. All right. What about this one? What's that thing called? It's not a polyhedron, is it? Okay. So it says then identify it. Tell us what it is. It's a cone. That's right. It looks like an ice cream cone, right? Turn it upside down, right? Stick some ice cream in there, all right? So it's a cone because it comes to 1 point. So it says if it's a polyhedron, name it. Well, it's not, right? It's not a polyhedron, so I can't name any of those things. But I can name a couple things. What's the bottom? It's the base, isn't it? And it's a circle. And You always name a circle. We haven't talked about this. We'll talk about it in another chapter. But a circle is named by its center. So I'd call this what? Circle T. Right. And what's the vertex of this? W. Yeah, easy. All right. It says the solid has a curved surface, so it's not a polyhedron. Okay, that's what we said. The base is a circle. There's one vertex, so it's a cone. Good. Here's another example. Oh, look at that. That's crazy looking. That's really weird looking. They didn't draw that very well, I don't think. I would say the base of this would be JKL. Do you think?
No.
No? I think it would be. So it looks like a triangular.
That looks like a kite.
It looks like a triangular something, right? So look, the only triangular thing I have is this one, triangular prism or pyramid. Sorry, right? Comes to a point. Yeah, it's not draw. I'm looking at kind of sideways up at the top. Okay, I'm kind of looking at it at not directly on top, but kind of off to the side a little bit from the top.
Think of it. All right, use your imagination. See where the dotted lines is at.
Yeah.
That could be the top right.
I'm looking at this as the third side of the base. That's what I'm looking at. I'm looking at this as the third side because you can't see it, right? You can't see through the solid. So this is one side I can see. So I'm looking at JLK as the base. Do you see that? It's a little hard to see, I agree. I'm looking at X as the very top of it as the vertex of
That's how
it.
you're looking at it.
That's how I'm looking at it.
But what they look at
Okay.
it
Well, first of all, is there any pentagons here? Are there any rectangles? Are there any squares? Not at all. So really, what's your only choice?
different.
Watch this.
Triangular.
Oops. I'm sorry. I think for some reason, I don't hit that arrow key. If I hit the... Yeah. I don't know why they do this, but they put this little percentage thing. I guess they have you raise your hand. Who says A? Who says B? Who says C? Who says D? Right? But then, watch this. See that bouncing ball? Isn't that cool? Watch. You want to see it again? Watch this. They should have sound effects with this. They don't, but it's kind of cool. Watch this. Boing, boing, boing. I'll put my own sound effects on here. So yeah, triangular pyramid. All right, look at this thing. What's this thing? Yeah, it's a cylinder. That's easy. All right, and boing, boing, boing. There we go. Not very exciting sound effects, but as good as I got. All right, what's this thing? Well, it looks like it's sitting on a rectangle, doesn't it? But do the sides go straight up, and do they all go to one point? Nah, so really, it is sitting. It looks like it's sitting on this right here, but remember like that other thing we did? Think of it as standing it up on end, right? Because it's got two bases. This is a base right here, and this is a base right here. Do you see that? All right, just because it's not sitting on it doesn't mean it's not the base. So this is a base, and this is a base. So what does it do? It goes straight up. Doesn't go to a point, so it's a what? Triangular, which one? Is it prism or pyramid? It's prism, right, because pyramid comes to a what? Point. A pyramid comes to a point. A prism just goes straight up and down, doesn't it? So let's see what they say this is. Boing, boing, boing. There we go. Yep, we were right. Okay. All right. Oh my goodness! Look at all these crazy things. I'm not going to worry about these words. Don't even worry about it. Yeah. Dodecahedron. An icosahedron. Icosahedron. I've never. Okay. Well, there it is. Dodecahedron. It's a solid with 12 regular 5-sided figures. We're not going to worry about that. Let's keep going. All right. This is what we want right here. It's in the book. It's on page 69. Okay. This is all in the book. So this stuff will be given to you. It'll be given to you in the book. Might be a good idea to write it down. But what we have to do here, this is very important. We're going to sit on this for just a few minutes, okay? You got to know what these letters mean. So you really, and it's all written right here, but you might want to maybe draw this. I don't know if you can draw this out. You probably can't, but just understand what this means. Look at this. We're going to find a thing called the surface area. So this T, I don't know why they use T. I think they use T for total. When I used to teach this, I would use SA for surface area. That makes sense, doesn't it? Okay. So I would use SA for surface area. They use T though. All right. You can put SA if you want. Okay, but I'm just saying T because the book says T. All right. So the T, the total surface area, that's why they use T, is equal to this. Look at it. It's pH. Now, what in the world does P represent, do you think? The perimeter, right? The perimeter of one of the bases. All right, see that? P represents perimeter of the base. So what do I do to find the total surface? Well, first of all, what's the surface area mean? It means all the area of every one of the surfaces all added up, right? So I find the area of the top, the bottom, the left side, the right side, the front and the back. But instead of doing that all individually, they give you a nice little formula that you can use, and you don't have to find out all those individually. So what do? You don't have to memorize this. I'm not making you memorize these, okay? But know what they mean. Know what they stand for. P is the perimeter of the base. So what do? I add up the lengths of all four sides of the base, don't I? Then I multiply it by the height. Now look at what the height is. The height on a prism is from one base to the other. Do you see it? See that straight up and down one, that perpendicular? That connects the top base to the bottom base, because there's two bases. That's the height. So you got to know what the height is. So just because you know the formula doesn't mean squat if you don't know what you're talking about on these on this prism. So we take the perimeter, the distance around it, multiply it by its height. Then what do? 2 times b. What do you think b is? It's the area of the base, okay? If you want to write these formulas down, it might be a good idea. You might not draw the picture, but write the formulas down and put a little arrow here for P and put perimeter of the base. Put a little arrow for this H and put height. Put a little arrow for B and put area of the base. Everybody see that? So you got to know what those letters mean. I probably will not give this on the test. Everybody looking? I probably won't say T equals total surface area, P equals perimeter of the base, V equals volume, B equals area of the base. I won't give you that stuff. I'll give you this stuff right here. Do you see this line all the way across? I'll give you all of those, and I'll give you all of these. And I'll say, for a prism, T equals PH plus 2B. On a pyramid, T equals 1/2 PL plus B. All right, I'll give you that stuff. But I won't tell you what these letters stand for. You have to know what those letters stand for. All right, so that's where you have to study a little bit. Make sense? All right, let's keep going with total surface area, then we'll go to volume. Look at the pyramid. Now look at that L. That L is what they call the slant height. The slant height. That means from the top, like if I sat on top of this pyramid, wouldn't be very comfortable. If I sat up there, okay, and I slid down that pyramid, sliding straight down that pyramid, okay, right here, that's the slant height. All right? If I'm sliding down the side of the pyramid, that's the slant height. Does that make sense? All right, that's what the L is. So what do you think this P is? It's the what? Perimeter of the base. That's right. This is the base. Make sure you know what the base is. So I just add up, right, all the sides of the base to get the perimeter of the base. Multiply by the slant height. Okay? It's the slanted part of this. And take half of it and then add it to B. What's base? Or what's B? It's not just base, it's what of the base? It's the area of the base. So I have to find the area of that particular base. Now sometimes the base is a triangle. Sometimes it's a square. Sometimes it's a rectangle. All right? So you have to know how to find the area of whatever that base is. All right? So there you go. Does that make sense? Do you know what these letters are standing for now? All right, let's look at the cylinder. Look at this. I only got two things on a cylinder, a radius and a height. That's pretty easy. So here's the formula. The total surface area is 2 pi RH. So it's just 2 pi, R, which is radius, H, which is height, plus 2 pi what? R squared. So you only square the radius. You don't square the pi. You don't have to memorize it. Okay? Just know how to use it. Know which numbers to put where. All right, so whatever the radius is, you put it in for R. Whatever the height is, you put it in for H. And then you're good to go. That shouldn't be too hard, should it? As long as you know the formulas. Yeah. Look at a cone. Now look at the cone. The cone has a height and a slant height. Look at the difference. The height goes from the center straight down to that vertex. Do you see it? Okay, that height is perpendicular to the base. Look at the L. The L is slanted, isn't it? That's why they call it the slant height. Makes sense, doesn't it? So look at the formula. The total surface area is pi r L. L is the slant height. It's this one. It absolutely makes a difference which one you use. So just use the one that's slanted. Plus pi times radius squared. So radius is this right there, pi r squared. And you say, well, why do they have H there? Because we have H for volume. All right? So we'll put that. We'll use the H for the volume, not for the. You don't have to use the regular H for the surface area. Look at a sphere. A sphere is pretty easy. 4 pi r squared. All you got to do is one thing. Know the radius. If you know the radius, you can find the surface area of that sphere. It's 4 pi r squared. Okay? Volume. What's volume? Well, volume is how much stuff you can fit inside of that solid. All right. So how many cubes? Exactly right. How many cubes, okay, can you fit inside of that particular solid? All right. That's what you're finding. And here's the formulas. Very easy. B is the area of the base times the height. So if you can find the area of that base multiplied by how tall it is, the height, that's the volume. Look at the pyramid. It's 1/3 BH. Now what's the H? I don't even see an H here. They should have put one. What do you think the H is? It's from the top. Where do you think? Straight down, perpendicular to the bottom. It's not the slanted one. All right? This L is the one that's going down the side of it. The height is from the top straight down to the middle, right, of that pyramid. Think of Indiana Jones. You ever watch Indiana Jones? Where he's on this rope and he goes down into that cave or whatever, and there's snakes all over the place. Remember that? Well, what did he do? He started at the top and he was lowered straight down into the middle of that thing. All right? That's your height. The slant height is if you slid down the pyramid, slid down the side of it. Okay? The actual height is from the top straight down the middle of it until you hit the bottom. Okay? All right, let me give you a worksheet before you go, and that'll be it.